Section 10.2 is about using statistical experiments. What we will have to do is find theoretical probability and experimental probability. Recall that the probability of event is the ratio of the number of outcomes in which a specified favored occurs and then the total number of possible. So remember, we just did favorable over possible. Those were our ways we were finding probability. Theoretical probability is what is supposed to happen. Okay. Experimental probability is your probability that is calculated from an actual experiment. Something we know is that as the sample size increases, experimental probabilities will be more closely resembling their associated probabilities. So you want to make sure you're doing a pretty decent size for your sample size. Okay, let's try example number 1. So a student tossed a fair 8-sided die 200 times and recorded those results. Find the theoretical and experimental probabilities of rolling an 8. So theoretically would be what actually should be happening. So this would be me asking you the probability of just rolling an 8. So there is one option on that die. So that's why it would be 1 on the top. And there are 8 options that I could get. So my theoretical probability would just be 1 out of 8. Now, if it asks for a percent, you can just divide . Okay, so you can divide 1 divided by 8. That'll give you this decimal, and then you can move that decimal point over 2 spots, and that will give you your percent. Your experimental probability is going to come from your experiment that you ran. So how many times did I actually get an 8 over the whole possible options of me rolling it? Okay, so I got 42 that I got for the top, and then I would divide by the number of times that the die was actually rolled, so 200, and then I would just reduce that. So 42 over 100 would change to 21 over 100, and then if you want to change that to a percent, you can just divide those two, and that's what it would change to. All right, pause the video and see if you can try the check question. So on the check question, a student is still tossing a die 150 times. They want to know theoretical and experimental probabilities of rolling a 5. So there's only 1 5 on my die. I'm saying that's a fair die, so that means there's 6 options. So I would have 1 out of 6. Changing that to a percent, I just divide those two, and then I would move that decimal point over 2 spots. So that's why I wrote it as 16.6%. Experimental is going to be based off of how many times it occurred when you actually did the experiment. So I'm looking at how many times I got a 5. So that's why I have a 24 on top. Put that over the number of times that I actually rolled that dice. So I got 150. Divide those two, and I got 0.16. And so I just changed that to a decimal, or sorry, to a percent. So I just moved that decimal point over 2 spots. All right. So you can run some simulations in order for you to figure out a probability. So a probability model is just a mathematical representation of a random event. It consists of the sample size and the probability of each outcome. A simulation uses a probability model to imitate a process or situation so it can be studied. Coins, dice, random number generators, those can be used to conduct your simulations. And we will use the number generator on your calculator. So these are the steps that we're going to use to run our simulation. We're going to determine each possible outcome of the situation and its theoretical probability. We're going to describe what our probability model is going to look like. We're going to define the trial for the situation, state the number of trials to be conducted, actually do the simulation, and then analyze what our results are going to be. All right, so here's our situation. A company that produces bottles of water runs a promotion in which 1 out of every 8 bottle caps wins the customer a free bottle of water. First thing we're going to do is just describe the probability model. So there are 2 possible outcomes. You can win a free bottle or not. So theoretically of winning a free bottle, so I would have a 1 out of 8 chance of me winning that guy. Your theoretical probability of not winning that free bottle would be the opposite. So since 1 gets me a win, the other 7 options would make me lose. So that's why I would have a 7 on top and then still 8 options for the bottom. Step 2, we're going to define our trial situation and state the number of trials we're going to actually conduct. I have a lot of extra stuff here that you don't need. That's why I cut it out of your note-taking guide. So we're going to use a random number generator. We're going to set the number 1 as the winner cap. We're going to set the numbers 2 through 8 as the losers. And then we are going to do this for 100 different numbers. Okay. Step 3, we're actually going to conduct this. So this is where you're going to get onto your graphing calculator. We're going to use the apps option because that's where your random number generator is, and then we're going to record what these numbers are. So your apps option is this button here. So hit that apps option. We want to go down to the probability simulator, so number 3. Then it should have something similar to this. Just press any key. You can see there's different options you can use for a simulation. We're just going to use number 6 for your random numbers. And then it'll take you to this screen. This is where all the numbers will be pulled, okay? Before you get started though, we need to set our simulation to what we want for our parameters. So I'm going to go to set, which is this option right here. It's going to give me numbers 1 through 6. You don't have an option. You can change it, I guess, those options, but you only get 6 at a time. So I just left it as 1 through 1, 2, 3, 4, 5, 6. In that row, I guess is what I should say. It gives you 6 numbers in a row. We want to range our numbers for what we had set up. So if you remember, 1 was the winner, 2 through 8 were the losers. So I want my numbers to range from 1 to 8. Do I care if they repeat? I don't care. So it is yes, they can repeat. So click that over to yes, and then click OK. Okay, now it'll take you back to the screen where it will actually generate your random numbers for you. So if you hit enter, notice it will give you that first line. So these were all of your random numbers that were generated on that first one. We need 100 of them. So I'm just going to jot them down here. So we got 4, 2, 8, 7, 5, 1. Hit it again. You'll notice it'll keep that first row and add to that second. So 7, 7, 4, 7, 3, 7. Just keep going. We need 100 of them. So I'm just going to keep going until I get close to there. The 10th row is going to put me at 60, so we're getting close here. All right, so on your 13th row, that's going to put you at 78. No, that's not right. Oh, yeah, it is right, sorry. Here's 60, okay. We're going to keep going. I got 84, 15, I got 90, 16 is going to put me at 96, And then, okay, so here's where you have 96 total. So I just need a couple more. So 97, 98, 99, 100. So those four. Okay. All right. So once you have all those random numbers, what you're ready to do is analyze your results. Okay. So I'm just looking at, you can get rid of all that. That just helped me figure out how many numbers I needed. So remember what I'm trying to do. I'm trying to figure out how many times it occurred that I would actually win. So remember, your number one is your winner. So I'm going to go through here and figure out how many number ones I have. So there's one. And it looks like that's all. Oh, nope, I skipped one. Make sure I didn't skip any others there. Okay, so out of 100, I got 1, 2, 3, 4, 5, 6, 7. Okay. So it wants to know what are your results. I got that number one 7 times. So that would mean that I would have an experimental probability of 7 out of 100. So you would become a winner about 7% of that time. So those are my results, and that would be my experimental probability of being a winner. Okay. All right. We got one more example here to try and run through and evaluate a simulation. So, a health club ran a promotion in which they sold tickets to their customers. 1 in every 10 tickets won free training sessions valued at $150. A customer complained that they bought 20 tickets in a row and they didn't win a prize. So, we're going to run and evaluate a simulation to decide whether the customer had a legitimate complaint. Okay, describing your probability. So, what are my two possible outcomes? I either win the prize or I don't win the prize. Talking about your theoretical probability. So, what should occur? Well, 1 out of every 10 should be a winner. So, there would be your theoretical winning probability. What would be me losing? 9 out of 10. So, the other 9 should make you a loser. All right, step 2, define the situation, state the number of trials to be conducted. So this time we had numbers 1 through 10. So number 1 is going to be your winner. So that'll be 10% of your chance. And numbers 2 through 10 are going to be the losers. Okay, we're going to do the same thing again. We get to do it 100 times and we get to figure out what those numbers would entail. Trying to see where I have space, so I might do that over here on this side here. Okay, so remember your steps again. If you're already here inside of your random generator, we can just clear out that whole, all those trials. So hit clear, it'll ask you, do you want to continue? Yes, and then it'll start right over for you, okay? But you do need to set it back up for your parameters. So I need to go back to set. I only have 6 numbers that it'll pull in a row. What's my range this time? I needed to start at 1 and I needed to go to 10. Is it okay that they repeat? Yes, it is. And then I hit OK so that it sets that. And then I need to start generating those 100 numbers. So here we go. So hit your enter. And then I'm going to start jotting these down. Now, obviously, these are randomized, so if you are doing this the same time as I am, you obviously would not get the same numbers. All right, 16th row is going to put me at 96. So I just need the first four numbers once I'm there. Okay, so same as before, we want to calculate how many times we got a number 1. So there. Okay, I think that's it. So 3, 6, 8. Okay, so when I did it before, I actually got 11 times when I did it. So in this case, we would just put that we got 8 out of 100. So 8% of the time there would be a winner. That would be my experimental probability of winning. How can this simulation be evaluated to address the concern of the customer? So we ran the simulation, we could run the simulation multiple times to see whether there are incidences where our spinner landed in the losing section or 20 times in a row. So for example, when we would do this multiple times, we would want to see if in a row it would occur 20 of our numbers. Like if we were looking over here, 6, 6, 6, here, this little stent right here, this potentially could tell you that you've got a little bit of a flaw in it because you got 20 tickets and you didn't get a winner. Okay, so if you can randomize and see how many times that would occur, that would tell you how often that might be. I can also see that down here that you've got a set of 20 numbers where it would also occur as well. Okay. So these people just continued to ask. Suppose the simulation was conducted 50 times and the spinner, they were talking about a spinner, but we used a random generator. And they landed in the losing sector at least 20 times in a row. So that would be 36 out of 50. In this case, the customer's experience is not unlikely and their complaint is not legitimate. Okay. Now, for me looking at these random generator numbers, I can kind of tell that us getting those 20 set of numbers, you won't get a winner every time you have a set of 20. So you would want to run this simulation a couple more times just to see how often that might occur. Okay, that concludes our statistical experiment.